Hello and welcome to another RLabs tutorial. Today we're going to be talking about how to produce scatterplots using ggplot. The ggplot2 package is an alternative to some of the other packages offered in R. It's a halfway house between the base R plot function and the lattice function. It combines the advantages of both of these packages together, and this has made it a very popular graphing application in R. Now you know where the ggplot2 package is situated within the R language. Let's tell you a little bit more about how to make a scatterplot in it. And essential to this is calling the geometric object geom-point. In doing this, we can start to create some very simple graphs, like the one here on our left, and then slowly modify them to make them look really pretty, like this one on the right. When you first see someone else's code for a ggplot, you may become slightly overwhelmed. But before you run away screaming, let's just consider line by line what the plot is trying to achieve. First of all, we have to create a ggplot object. Then we have to add layers to this ggplot object. And then we might want to change local and global options of this specific plot. So the ggplot object consists of passing a data frame to it and then mapping variables to be represented as X, Y, and Z variables in the plot. To this, we add the layers of a geometric object, for instance, the points of a scatterplot. Other layers include faceting, which allows you to compartmentalize graphs into a series of panels according to a variable, or add statistics to it, such as plotting a linear line through the data points. And finally, you can add scale and coordinates. Okay, so now we have a basic idea as to format of writing ggplot code. Let's jump back to RStudio and read the data that we need to start producing this plot. Okay, so let's open the library ggplot2, and we're then going to set a working directory. You can set this to whatever you like, but you must make sure that you store the CSV file that you're about to call within this working directory. Once this is done, it makes it very simple to read in our data. And let's get a quick idea of what this data consists of. So we have 4 column variables, which are named year, geo, sector, and something about the CO2 annual production in kilotons. The first thing I'm going to do is create a new data frame where we remove all rows that have the sector equal to total, or all sectors. In other words, we're interested in comparing each sector by sector, and not each sector to the grand total of all sectors. So with this new data set, we can run the code that you've just previously seen, and it produces something like this. Oh my god, this is ugly. Why doesn't it look like what we have on our presentation from earlier? Well, it's just because it's a very big plot and we need to adjust the dimensions of the panel here. And as we do that, it'll automatically resize to something a little bit more pleasant. One small change that we can do to this right off the bat is to apply a theme to this panel with just one small line of code to remove the grey panel background and to reduce the contrast of the grid lines. And that was done just here. We just added theme underscore BW, black and white, and it's automatically made this maybe a little bit more aesthetically pleasing. But we're still a long way to go to get this graph looking anything like we want it to. The problem that we face in this graph is there's so many levels within the factor sector. In fact, I think there's something like 170 different sectors that we're trying to graph out here. Maybe for the purposes of visualization and keeping the story simple, it would be easiest just to plot the first 10 sectors that contribute the most CO2 annually. To do this, we're going to have to go ahead and do some more data wrangling. And of course, because we want to do some data wrangling, it's time to open the package dplayer. Okay, So the next 3 lines of code do quite a lot, and they rely on understanding how the chain method works. So let me run them and I'll explain what's going on. These 3 lines of code try to create a new data frame where there's just one row for each sector, where we've averaged and taken the mean of the CO2 annual production across all years, and we've arranged this so that the largest numbers are at the top and the smallest numbers are at the bottom. So how do we go about reading these 3 lines of code? So we start off with our old data frame, then we're going to group this data frame by sector, then we're going to summarize, where summarize is equivalent to the base R aggregate function, and we're going to create a new variable, co2.mean, which is the mean of the CO2 annual production in kilotons. Then we're going to arrange this data frame, making the co2.mean descend, so the highest values at the top and the lowest values at the bottom. This data frame is then assigned a new name. And we can index the first 10 elements of this data frame. So here's the new data frame that we've just created, co2.data.sector.order. We're going to index, and we're interested in the first 10 rows, and we want all data for the columns. This then is saved to a vector, which is the dot top 10. And if we print this to the console, here are the top 10 evil sectors that are contributing the most to CO2 production. And we can even specify element by element of this vector. Okay, so now we've figured out the top 10 major sectors that contribute to CO2 production. We can then revisit our old data frame and index for just these sectors and create a new data frame. And with this new data frame that we've created, we can then rerun our ggplot code and produce a much simpler graph with less sectors. Okay, and that gives us something like this, which is very nice. We can drag it out, resize the panel. At the top we have the business sector, which is producing considerably more than all the others, especially as we consider this variable is log scaled. Interestingly, now we're looking at just 10 sectors. We can see that some sectors have been stagnant over the last 20 years and have not grown in the amount of CO2 that they're contributing, such as the primary metals manufacturing and crop and animal production. Whereas some sectors, like the business sector and truck transportation, seem to have been growing in how much they've been producing annually. This graph still could be tinkered with to make it a little bit more pleasing. We could maybe get rid of the border around the plot. We could modify these axes labels to make them a bit clearer, and maybe even get rid of the major grid lines. So to do this, we have to add quite a chunk of text, but it is quite simple to understand it. So the previous plot was just maybe 3 or 4 lines long, and now we've added substantially to the theme of this plot. We've made the plot background blank. We've made the major and minor grids blank. We've specified exactly the size we want for the x-axis and the y-axis. And finally, we're able to add the exact palette of color that we wanted our 10 categories of sectors to be colored as. So I hope you found this tutorial useful. Just remember, when you're trying to write your ggplot code, that you have to think about the ggplot object, the data frame that you're passing into it, the aesthetics of how you have to map certain variables onto the graph, and the layers that you want to add. Thank you for listening to this RLabs tutorial video. If you found this useful, you may be interested in our free online Moodle course, or check out and subscribe to our YouTube channel.